Okay, so now we're going to be solving logarithmic equations. In 8.5 we did exponential equations. You've experienced that in the past already. Logarithmic equations to solve, you haven't. So that's what 8.6 is. Notice I'm putting this on the board every lesson, and I'm going to say it every single day, how important it is to understand that principle. It's going to get you out of a lot of questions, as you will see today on the board. So first of all, you're going to have some experiences with using log on one side, log on both sides. So these are just different scenarios that we're going to go through that will help solve logarithmic equations. It's not that I know it's going to look easy. Sometimes you have to use multiple of these strategies at the same time, so it makes it kind of a little harder than you might see. So first of all, solving means find the x value, whatever the x value is in the question. We know that already. If I have a situation like this with a log on one side, I can go right into exponential form. X to the negative 2 is 0.04. X to the negative 2 is 0.04. A few ways I can do this. I can turn this into a fraction and reduce it. So this is 4/100ths. I'm not going to write that down though. 4/100th is 1/25th. So x to the negative 2 is 1/25. Okay, I can turn 1/25 into a base with a 5. So I can say x to the negative 2. Well, this is just 5 to the negative 2. Okay, or 1/5 to the negative 1/5 to the 2. So flip it, 5 to the negative 2. So a lot happened here. We have to understand our negative exponents. And now that the exponents are the same, I can match my bases. Therefore, x must be 5. Could have also changed this into a 1/x squared and then match the base. But it doesn't really matter which way you go. Okay, next method, if you have a log on both sides, just like when we find the exponent, we find the log of both sides. Usually it's the common log, base 10. Well, this is just base 7. But both sides have base 7, the entire side. So we can actually just get rid of the logs on both sides. We have 3x minus 5 is equal to 16. So 3x is equal to 21 if you add the 5. And then divide by 3, and you get 7. And yes, it's that easy. Remember, it's only that easy because this is linear. Right? It's linear. Next, okay, we're going to get to the easy step like this, but first we might have to use our laws of logarithms to get there. I can't have multiple logs to solve. You notice over here there's one thing on each side, right? So over here I have multiple things, so because I have the same base with subtraction, I can use my log law to divide 30x by 5. So I can rewrite this log 2 of 30x over 5 equals log 2 of 12. I can reduce that. Sorry. It's going to be a log 2 of 6x is log 2 of 12. Now I have that same scenario. Log on both sides, so just 6x equals 12. 6x is 12, therefore x must be 2. Done. Sometimes it might not be something as easy as a 6x. We might have higher degrees. Okay, greater exponents on x. Harder to solve, greater exponents on x. We know in grade 9 it's like linear, just x to the 1. Then if we have x squared, if we can get out using the square root, yeah, we can get out. But usually we'd have to use factoring or quadratic formula. Then we have x to the 3. Well, now I got to bring back factor theorem and then quadratic formula. So never forget how we solve higher degrees. Here I have an addition with log base 10. They're both the same. So I can say this is log base 10 of x to the 3 equals 12. And sometimes we get stuck with a log base 10 because we don't see that 10. Over here we saw that x. X to the negative 2 is this. But sometimes just because it's not written, it avoids our thought. So this is just going to be 10 to the 12 is x to the 3. And now, if I can break down the 10 to the 12 into a variant of a power of 3, I can find my answer. So I can break the 12 down into a 10 to the 4 to the 3. Now, because the exponents are the same, I know x must be 10 to the 4, if you can see that. So 10 to the 4 equals x. But I have a better way from here. I can use another log law here, and I can bring down that 3 in front. So I can say this is 3 log of x is 12, and then I can say log of x is 4 because I can divide by this 3 now that it's a multiple in front. And now 10 to the 4 equals x, and I'm at my answer. Okay. I think I prefer this way because this required a little bit of thought, and if that's not a 12, it's something else. It might take more thought. This was just really straightforward. Okay, last one. You might not just get an x squared or something easy. You might get an expression or an equation that is quadratic, that is cubic, whatever the case may be. So here I'm going to use my log laws because I'm adding two logs that have the same base. So I'm going to multiply these guys in here. So it's going to be log base 2. I'm going to open up square brackets and show this multiplication. I have to multiply those two. Well, it's a difference of squares, so that's an easy one. If it's not difference of squares, just expand. Okay. Nothing's changed. I still have to get out of this and solve for x. So I have to go 2 to the 4 equals this. 2 to the 4 equals x squared minus 9. 16 equals x squared minus 9. Bring the 9 this way. 25 equals x squared. Now I have to find the square root of 25. So square root of 25 equals x. Don't forget your plus minus for the rest of your life from grade 10 and on. So plus and minus 5 equals x are my two answers. But I have to check. I should have been checking, to be honest, if I can plug this. Like, can I plug this 2 back into the question? Yeah, log 2 of 60, and that's still log 2 of 5. I'm good. Okay, I still have to check. When I have multiple answers, I might have to reject one. So what I'm going to do is I'm going to actually plug them into the question. So if I plug in x equals 5, I'm going to get log 2 of 8 plus log 2 of 5 equals 4. Okay, and I can check whether this equals 4 or not based on my findings here. I should have left side equals right side, or else I'm wrong. So let's try to do negative 5. I'm going to have log 2, negative 5 plus 3 is negative 2, plus log 2 of negative 8, and equals 4. Now, I could still use log laws and combine this to a positive 16, and I'm still going to get 2 to the 4 is 16. I'm still right, algebraically. But this cannot exist. This cannot exist. So because I can't find the log of a negative value, because 2 to the nothing is negative 2, it's impossible, we learned that in previous sections, I have to reject the negative 5 and say, therefore, x can only be 5. Okay. Although there's two answers, reject the negative 5. Now I'm rejecting the negative 5 not because it's negative, because I'm plugging it back in and getting a negative. There could be times where you plug in the positive one and you're not going to get the right answer, so just be aware. Plug it back in to check. And that's 8.6, solving log equations.